Well, hi there. Today I want to show you a concept for a storage system that I've been working on for quite a while, and I think I've reached a point at which I don't want to work on it anymore because of certain changes in the game and the fact that it uses a lot of redstone. So I want to show you the way I've designed it and the different machines that go into making it work. So here is a button panel and 7-segment display that I designed for my storage system. Basically, it has 16 buttons, each one of them corresponding to a different digit in the hex number system. So I can type in 2 digits, and those will show up on the display, and then those digits will be stored as binary, which can then be sent to the addressing system for the storage network. And then an item can be retrieved based on one of the 256 possible combinations for these bits. So the way this button panel works is we have 16 buttons. 0 through 7 are on the bottom, and 8 through F are on the top row. And there's a reset button that will reset all the outputs back to 0, and a request button which can go to whatever system I have to request from the storage system. So what I can do is type in 2 numbers, and the only rate limit is the time it takes for a stone button to pop back out after being pushed in. So basically I can hit a second button right after the first button has come out, and that was one of the challenges with designing this to make it quick. So it's kind of dense over here, so I guess I'll explain it by pulling 2 parts out. So the way I designed this button panel was with 2 slices that can be tiled right next to each other and not interfere. And the way both of these work is by ORing the upper and lower buttons together to form one signal, which will then go to a 3-bit decoder. And the way this decoder works is basically, if I have a torch here or not, that'll determine whether the signal is read as a 0 or a 1. So once this redstone receives power from either the upper or lower button, it'll turn these torches off unless there's a torch missing, in which case the torches that are turned off will turn these torches on and turn on the lines indicating that those bits should be on. But because hex digits are actually represented as 4 bits, not 3 bits, I had to have some way of having those 3 bits plus a 4th bit, and the way I do that on both sides is simply by taking the output of the top button only. So as you can see from the way these are written, the bottom we have 0 through 7, which all have the most significant bit as 0, and the top are A through F, which all have the most significant bit as 1, and that's how we can have these buttons so close together. So, if I press either one of these buttons, you'll see that the torches over there will turn off, but only if I press the top button you'll see this repeater turn on, and this redstone will turn on, though you probably won't be able to see it from this angle. So the bottom button, torches turn off, top button, this redstone line turns on, and so the way I have it laid out is I have the least significant bit over here, so this would be the 1's bit, and then the 2's bit, 4's bit, and the 8's bit, which is the most significant bit. I know it's not the best order to have the bits in, but because of the way that it goes to these storage cells, which are basically just using locking repeaters, I can unwind all the bits and send them to their correct positions in the byte that is being stored. Also, you may have noticed these lamps, which indicate whether you're typing in the first digit or the second digit. So if I hit one button, it'll switch to that one. If I hit another button, it'll switch back to the first one. And if I have 1-digit input and hit the reset button, it'll take it back to the first one. And the way that works is just, I have a monostable circuit down here, which will send a 1-tick pulse to this piston and drop off that slime block. and then these repeaters will power through the granite block either one side or the other side, and that will go through a torch and go unpower these locking repeaters for just a second to allow the data to be stored in each storage cell. So another component of my storage system is having a 7-segment display to be able to display the number that I put in on that button panel over there. So the way I've designed it, it takes 4 bits per digit, and because hex has 16 digits in its number system, then I can take those 4 bits and decode them into one of the hex digits using this system. So the way this works is by successively halving the space of possible values from the 16 values that it could be, and ending up with just one line turned on that goes to the display driver. First of all, we have this inverter, so if this is powered, the higher 8 will be turned on, but if it's not powered, the lower 8 will be turned on. And then those go through these pistons and slime blocks and granite blocks, and based on whether it's a 0 or a 1, these will be either extended or retracted. So you can see right now we're selecting for the lower half because these ones are extended. But if I flip that lever, then those retract and this extends, so now we are selecting for the upper half. And then it goes on again to do it with every 2, so the lower half of 4 would be these 2. And then for the 1s bit, we just have a single block which will either be here or one farther along. So now as you can see we're selecting for the upper half of these 2, and that goes to one single input on the display driver. So the way the display driver works is by having a torch tower and then having torches and repeaters as outputs to determine whether a line should be turned on. And I'm just alternating between torches and repeaters so I don't have to invert the signal multiple times. So for example, I only have the digit 0 programmed in right now. 0 has this turned on, but not this one. This line turned on, and then all these 3 lines turned on, based on the placement of these torches. So if I were to program in the entire 16 digits, then I would have a placement of torches and repeaters that would identify each digit, and then I would have the same on the other side. So I built this system so it could be mirrored, having the display driver slightly below and on one side of the torch tower. So that allows me to have these displays only one block apart, which would make them a lot easier to read than having the displays farther apart. So now to the way that items are actually stored in this storage system. Here I have a single storage cell that I designed, and these storage cells can be tiled next to each other, and they can also be tiled back to back, and they can be tiled as part of this hallway so that chests are accessible if you need to access them manually. But the idea is with this storage system that you have items flowing in on a nice stream, and those will be aligned so that they can be picked up by these hoppers while still keeping their velocity on the ice. And this is just a fairly simple item sorter that I've kind of crammed in here sideways in order to be able to sort items into the system. And then those go into a chest and a hopper chained all the way down here. And then there's a hopper facing into this rail where a storage minecart will be sitting. So the storage minecart will be the base storage for all items. And when you want to request something, you would simply power the block below to send the storage minecart off on this rail, which would go to the area where you'd pick the items up. So here's an example of a storage cell I already have set up, outlined by these glass blocks. So I have a storage minecart, which I'm going to click on it. You can see it has cobblestone, and it also has a stick, which has been renamed. And that is how I'm able to sort the minecarts back into their respective spots. So I have an item sorter here with that same renamed item, and just a filler, like a normal item sorter. And then the output from that item sorter goes into this block, which then powers this repeater to switch this rail for just a couple ticks. And then basically if a minecart that contains that item passes over here, it'll trigger that rail switch, which will cause that item to be sent back down into its holding area down here. But if it does not have that item, it'll simply continue on until it finds a storage cell that it fits into. So I'll give an example of that. If I power this, it'll send off the cobble cart, and it'll get switched and sent back into its area to be refilled. We can do the same thing. There's a cart down here, which is full of dirt. You can see that comes out, and then presumably the user would interact with it, and then it would come back and be sorted into its proper spot in the system. So the dirt's back here. I don't know. Sugarcane, we can send that out. See it get sorted into the third cell. Now you may be wondering why I didn't simply build the cart sorting system by taking out a single item from the cart, say for example sugarcane. But what if the user was to take all of the items out of the cart? Then there would be no more sugarcane to actually sort it. And there's no way to tell that there's not a cart in each cell because I'm using powered rails to push them out, so I can't use detector rails to detect if the cart's there. So I decided that the easiest way to do that would be to have some sort of named item that I can put in each cart. So even if there are no items that match that, you can still sort the cart back into its proper space to receive more items. Also, here I have a fairly simple overflow detector. So I just have one comparator reading the output of the topmost chest, and then another comparator in subtract mode subtracting 15. And once this chest fills up completely, then this torch will turn on, locking this hopper and powering the block above it, so it will lock this hopper. And that'll just prevent these item filters from getting messed up by picking up too many items. Also, as part of the way the cart sorting works, we have this item sorter, which would pull a single item out of the cart, and if it matches, then we take it through this hopper and this hopper, which is pointing into the rail line. So if the cart gets an item pulled out of it for sorting, it'll automatically get it put back in by this hopper, so it will never lose the items that it has that are used to sort the cart into its proper place. So here I decided to stop with my customary building style of stone brick and use some concrete to prototype something. So this is a binary sending device, and what it does is you have as many bits as you can fit into a chest. Here I just have 8 bits because my storage system uses 8 bits to refer to each item. But these are stored as stackable and non-stackable items, and if you know, if you put these items through a hopper, then the non-stackable items will give an output of 1, and the stackable items will give an output of 3. And that's the way this data is encoded. So I have a clock line that is pulsed every time a bit is sent, and then a data line which is only pulsed if that bit is 1. So it's fairly simple to encode. If you've ever worked with microcontrollers, there are a number of communication schemes that use this shift register type data transfer method. But basically, the receiving end will check if the clock is on and the data is off, then we've received a 0. But if the clock is on and the data is on, then we've received a 1. So, let's look in the chest again. Our byte that we're going to be sending is 011011011. And if I send that, you can see that 011011011 appears. And then this line turns on to show that we have finished receiving the byte. So this is a fairly simple shift register that uses way too many locking repeaters. We have a monostable here for the clock line. And so if the clock line is pulsed, it'll turn off for 2 ticks because of this repeater to extend it, which is just long enough to unlock these repeaters and have the signal travel 1 over. So let's reset the system. And then I'll trigger the clock line once. And you can see that this power level has now moved up to here. and if I trigger it again, it'll go up to here, and so on. And then what this does, it just branches off and goes to a locking repeater that will lock to store the data that's coming in on the data line. So if I press this again, now power level has advanced to the second bit, and now the locking repeater down here is locked to store the data that came in on the second bit, and so on and so forth. Now obviously I wouldn't want to have to come back here and press reset every single time I wanted to send a new byte. So what I figured out that there's an edge case, because obviously if you're sending data, the clock is always going to be 1 when you're sending data, and the data is going to be 1 or 0. But if we pulse the data line without pulsing the clock line, then that'll be picked up by this system, which is just a simple gate, which will send a signal to the reset. So that is why when I trigger this, I first have to send a signal directly to the data line, and then after a short delay, the system will start working. Let's watch that. It'll send a signal to reset, and then you can see as the pattern of zeros and ones gets sent, the clock will pulse and the data will pulse on and off based on that. And then if you look in here, we still have our byte in the same order. So if we wanted to change that order, it's pretty much as simple as clicking and dragging a few items into whatever byte you want to make. Or you could even store up to 56 items if you made this into a double chest. So now that byte we have 100111110. If I send this again, it'll reset, and then after a couple seconds we have our byte ready to be used as an address in the storage system. So the system is fairly simple. Basically, this hopper is locked all the time until you send a signal to this block, which will unlock this hopper clock, allowing an item to flow over here just long enough for this hopper to pull an item out of the chest and put it in this dropper, and then lock it again. And as soon as we have an input in this dropper, then this comparator will detect that, send a signal activating both droppers, and then it'll go through this hopper, and then get the output through this comparator, which is sent along. And since this hopper is not locked, it'll simply flow into this chest after a couple ticks. It's still long enough to send the data. And what I have here is just a simple comparator burnout timer. So every time something passes through this, the signal will travel up to here, refreshing this, and powering this block, which will keep this hopper locked. If I watch here, this is going to get all the items in order. And then once it unlocks, they're all going to be pulled out in the correct order and put back into the original chest, so it can be reused again. So here we have a semi-complete assembly of the full storage system. What I have is 256 of the storage cells that I already talked about. And those are arranged in these halls so that if you need to, you can go retrieve items from the chests. But of course, walking around these halls is kind of boring and it would take a long time. So I have the hex button panel and 7-segment display hooked up here as well. So I can type stuff in just like I normally would. Now I don't have all the numbers programmed into the display driver because, as you can see, this one's blank. But that'll output the binary digits, which then go to these piston-based 16-bit decoders. So you can see this one has the number 1 typed in, so it's selecting number 1, and this one has the number 3 selected, so it's selecting the third line here. So where these intersect is an AND gate, so this line is powered and this line is powered, which means that this torch is going to power the rail up here where a minecart would be sitting to send it off to a pickup room. So these piston-based 16-line decoders are fairly similar to the ones I've already demonstrated for my display driver, but what it does is each junction has 2 repeaters facing into a block, which is either extended and powers one side, or retracted and powers the other side. So you start with a signal, it either selects for the upper half or the lower half, and then the next level selects for the lower 4 or the upper 4, and then the lower 2 or the upper 2, and then finally selecting a single line with the last piston. And then each line will go to the lower level here, and it also goes up these ladders to the upper level, so that the upper half of the bit space can be addressed. So the shift register can receive binary data coming from any system in the world that wants to request items, and it will decode that into 8 bits. And those 8 bits then can be applied. Basically, I have a system here with pistons and some gates that will allow me to switch between manual mode, in which the button panel determines what the address is, and automatic mode, in which the shift register determines what the address is. So just for a demonstration, I use levers to power these outputs of the shift register, which are then taken on and put into the address system. But if I flip this switch, it'll go back to the address that we previously typed in on the button panel. And then I can flip it again to go back to the automatic mode address. So basically, when the system is in automatic mode, the output of the last locking repeater in this line basically means that the shift register is finished receiving data. So I send that down here along with the input from the request button on the button panel, and that will cause some pulse extenders and lock the repeaters that are storing the data, so that if you start typing in another digit before the request is done, that it won't actually interfere with the data that's currently going to the address system. And then we'll also send a pulse, a fairly long pulse, that goes to both this input and this input over here, that will send the bit through each of these pistons and to whichever gate you have selected, which will send a cart out by powering one of these powered rails. So as with everything else I'm showing you, there is a good reason for me building this binary sending system. So what I wanted to be able to do with this storage system, and I haven't quite figured it out yet, is to be able to just have a simple 1 or 2 lines of redstone leading from somewhere that would be able to request an item from the storage system and have it sent to it via rail. For example, if you wanted to automatically smelt cobblestone into stone and keep a certain amount of that somewhere, you could have a system that would detect that and then send a pulse to this, which would then send the binary for cobblestone, and that would travel along here to the shift register receiver at the storage system, and then the storage system would take those 8 bits, send it to an address system, and request the specific item, and send it along a rail to wherever it needed to go. So here's an example of that I've been working on, but I haven't managed to finish quite yet. Basically, you would have a chest, and you could store, 5 to 6 different items in that chest. And when you wanted to, you would send a signal which would unpower a hopper under the chest, pulling all the items out into this hopper line, and then each item would get sorted with a fairly simple item sorter, and it would go into a buffer chest. And then I have a furnace over here with a number of sticks in it, and however many sticks I put in there would indicate the approximate fill level that I want this chest to have. So I have a system of comparators with subtraction here, and what it would say is if there's less than that number of items, so 32 sticks in one slot means approximately 1/6 of the inventory full. So if I steal some sandstone here and put it in, you'll see this torch is off right now, but if I fill that up so it's more full, this torch turns on, which means that we don't need any more items. But give an example of a storage system that does not have enough. I have a furnace here which has 32 sticks, so it's 1/6 full. But this chest is less than 1/6 full, so this torch is off, which means that when it's activated, each storage cell will check whether it does not have enough items, and then it will send a signal to the binary sending device that I just designed. And then that binary sending device will send along the data, which would go to the main storage system, so it could request an item which would travel by rail. So that goes to a cart sorter. This cart sorter would have items in here in order to detect when the cart passes by, and then the cart would just come down here. The cart would just come down here and have the check item put back into it, and come to here. And so this powered rail, which is off right now, would be off until the comparison chest filled up sufficiently. So here, for example, is what would happen. You have your minecart come in, and it would sit there until this chest got filled up sufficiently, and then the rail would turn on, sending the cart out here. And of course, these rails would be powered, sending the cart out here back to the main storage system so that it could be sorted again. Once all these chests have been filled up sufficiently, then I would unlock the hoppers underneath them, and allowing them to travel into a dropper elevator, which would take them back into the chest. So the idea behind this is that you'd have your main storage system over there, which is, very large and hard to get around. But if you just wanted a chest full of, say, the ingredients to make pistons, then you'd always have those accessible every time you were to trigger the system to request them. Right now, however, I'm just having a lot of trouble getting the logic to work and detecting if a cell is not full, then we need to send this signal with the binary sending device. But if it is full, we want to skip that cell and go on to the next one and not send the binary because we don't want to bring carts here if they're not needed. I would just take extra time for the storage system to run and extra time to send the data. So, haven't quite finished that yet. So as you can see, the storage system is quite large, and I think, even though it was fun to build, I think it's probably too large to ever implement in actual survival. So, I think it was a fun project, but I do have some other ideas. I'm not going to be continuing this one for very long now. It's not in a working state right now, so I won't be giving a world download or anything. But if you're interested in some of the machines that I've designed, like this button panel or the shift register, I can give them to you if you want. This was actually designed a long time before shulker boxes were added to the game. That's why I used minecarts. But now that they are, it allows for a lot of different designs on storage systems. I won't have to have a quite as large bulk storage because I can just store it in shulker boxes and have loaders and unloaders, and it is possible to sort them. Anyway, I'm probably not going to be returning to this particular project for a while, but It was definitely fun to learn about all the binary and cart sorting and item storage ideas that I came up with. I hope you were at least a little bit entertained and enlightened. Thanks for watching.